So in the last video, we looked at limits at infinity and the infinite limits. In this lesson, we will be looking at some examples, and I will be showing you how you can tell your answers before you evaluate the questions. So let's get into it. For our first example, say we have the limit of 5 over x as x approaches infinity. We know from the previous lesson that this would be, by the way, this is 5. Let me fix this. We know that this would be 0, right? Because of what the graph 1 over x look like. And for our second example, say we have the limit of 3 over x squared, and this is as x approaches infinity. Again, this would be 0. So we know that 5 over x would be similar to the function 1 over x. Let me refresh your mind of what the function 1 over x looks like. The function 1 over x, or in fact, a function where the denominator, where the x is raised to an odd power, then the shape of the graph would be shaped like this. They might be further away from the horizontal and vertical. The asymptotes would be axes in this example, but what I'm saying, for 1 over x or 2 over x or 1 over x cubed, any odd power here, let me put the 1 in red here. Remember, there's a 1 here, and 1 is an odd number. So for any odd power in the denominator x, then your function would look something like this. Let me bring it up closer to the function there. So that is what our 1 over x would look like. This is the same thing as 3 over x squared. And the function of this would look like this. That is what they look like. And this is for all exponents that are even power for x when you have a constant over x. The software is graph if you would like to use this software. So if I'm supposed to now enter my functions, for my first function, 1 over x cubed, or 1 over x. We know what 1 over x looks like, right? In the first quadrant and in the third quadrant. So when I press OK, I will have my graph blue. Let me put it in red so we can see the graph. So this is what the functions look like when there's an odd power for x in the denominator, right? Now, if there was a even power, let me do this in yellow. Even power, so say I have 2, or yeah, it doesn't matter, 1 over, as long as there's a constant, no variable, 1 over x to the 4th power. Remember, the 4th power is even, so I should have a curve in my first quadrant and in my second quadrant. And here we go. So this is the graph I was showing you here. This would be for even powers, this would be for odd powers. And both are approaching 0. So as I approach infinity, remember we're approaching infinity. So as I approach infinity, my function approaches 0. And I shouldn't even be explaining these in this video because I did a video on this already. So if you want to watch that video, it is the video before this in the playlist. Now onto our third example. Say we have the limit of 4x squared minus x plus 2 over 8x cubed, that's a x, plus 5. And this is as x approaches infinity, right? This is our question. Right away, we see if we plug in infinity, we would have infinity over infinity, which is indeterminate. But let me go ahead and show you this for this first example. So this is what we'll have: 4 times infinity squared minus infinity plus 2, and all of this would be over 8 times infinity cubed plus 5, right? If I square infinity, it is, even though it's infinity, it is quote unquote larger than this infinity, right? When I square it, because I'm multiplying it by itself. When I multiply it by 4, it is 4 times larger than what it was when I squared it. And when I add 2 now to infinity, which is a really small number, 2 to infinity is really small. It doesn't change it that much. So it's basically the same infinity, right? Multiplied by the infinity times itself times 4. So when we subtract this, let me do a little note here so I'm not confusing anyone. If you see this in a book, infinity minus infinity, then this is indeterminate, right? But even though we'll end up with infinity minus infinity here, we are looking at it as this. We multiply infinity by infinity, so it becomes larger, right? And then we multiply it by 4, making it larger again, subtracting infinity plus 2 from it, making it infinity the same. So this would just be infinity in the numerator. And this would just be infinity because I'm cubing infinity, multiplying it by itself 3 times, and then multiplying it by 8 and adding a 5. So I will just have infinity. So that is again indeterminate. So how we do these questions, as in the previous video, we divide each term by this x cubed here. So let's do that. When I divide 4x squared by x cubed, I will be left with 4 over x, right? Minus x divided by x cubed, I'll just be left with 1 over x squared and 2 over x squared. Well, x cubed rather. So this should be a cube. So in the denominator, we have 8x cubed divided by x cubed. So I will be left with 8 here plus 5 over x cubed. Now, from the previous video and in the first two examples, we know that this would be 0, this would be 0, this would be 0, and this would be 0. So here, this would be 0 minus 0 plus 0. All of that is over 8 plus 0, right? And we know that this would just be 0 over 8, which is just 0. So the limit of this function is 0. So pay attention to the limit and pay attention to this x squared here and this x cubed. I will be coming back to these. So on to our fourth example. Say I have this question. I know the answer for this already, and by the end of this video you will too, by just looking at this. So remember, this must be approaching infinity for the tips I will be showing you when I'm through with working out these. So straight away we see that this is infinity over infinity, and if you are not seeing that this is infinity over infinity, which is indeterminate, I will just go ahead and show you right here. Let me do that in red. If I multiply infinity by itself 3 times, this would just be a larger number than what infinity is already, right? So remember that infinity is just a really large number. So when I multiply it by itself 3 times, it makes it larger again. So this would just be equal to 6 times infinity plus 5. And all of that is over 2 times infinity minus 8. When you multiply 6 times infinity, an infinite number multiplied by any other number will just be infinite. I will just be left with infinity plus 5 over infinity minus 8. And when you have a really large number and you add a number like 5 to it, that doesn't change it much, and it in fact makes it larger, but not by much. So it's still just infinity. Infinity minus 8. Imagine you have a really large number and you subtract 8 from it. This 8 is so small it doesn't really affect what infinity is. So infinity will still be a really large number. Even when you subtract 8 from it, it will still be a really large number. So this is why I have infinity over infinity. So let's get back to our question. Remember when this is an x, by the way. So remember, when we are dealing with limits at infinity and we have it in a fractional form, we look in our denominator for the x term with the highest power, then we divide each term by that. If I divide 6x cubed by x cubed, I will just be left with 6, right? So I'll have 6 plus 5 over x cubed. And then 2 minus 8 over x cubed. Now we know that this would be 0, right? Let me go back to the graph. We're just using the 1 over x, or in this case 8 over x cubed or 5 over x cubed. It doesn't matter. Both graph will look very similar. As we approach infinity, that is in this direction, then my function get closer and closer to 0. You can see that as I get closer and closer to infinity. And even though it looks like it touches the x-axis here, it is asymptotic to the x-axis. So that is why these will be 0. If the 5 over x cubed will be 0 and 8 over x cubed will be 0, I will be left with 6 over 2. And 6 over 2 would just be 3, right? So the limit of my question would be 3. By the way, let me leave this as 6 over 2. And I have a reason why I'm leaving it as 6 over 2. I will explain it when I get back. So remember this 3, this 6 over 2, and remember the x cubed here and the x cubed in the numerator. And we are now moving to our fifth example, where we will have, say I have the limit of 3x squared minus 5 over 7x plus 3. This is as x approaches infinity. If I directly substitute infinity in this would just be infinity over infinity, right? And I don't think I have to explain this again. It is indeterminate, right? So I will divide each term by my highest x power. My highest x power here is 1. So I will divide each term by x. So I'll have 3x squared divided by x would just be 3x, right? Minus 5 over x. All of that now is over 7 divided by x would just be 7, right? So this would be 7 plus 3 over x. This is what I would get. Now we know from this that this would just be 0. These would be 0. The 5 over x and 3 over x, they would be 0. But what is 3 times this? Remember, we're finding the limit, by the way. I should have the limit here to show that I'm finding the limit as x approaches infinity. I should have the limit. I'm sorry for not having the limit here, but I'm finding the limit of each term. So as x approach infinity for 3x, this would be infinity, right? And for this, as x approaches infinity for 5 over x, this would be 0, this would be 0, and the limit of a constant is just the constant. So I'm left with this. In fact, let me write that out, because I don't want anyone to be lost. This channel, as I said many times, is for helping those that need help. So let's do that. So the limit of all of this as x approaches infinity. For this section, remember we can use limit theorem to split this up and find the limit of each term. You know that this would be infinity, this would be 0, this would be 0, and the limit of a constant would just be the constant. So my limit would just be this, infinity over 7. And some teachers would accept this as the limit doesn't exist. Others would accept this as infinity. 7 divided by infinity would be infinity. Now that I have done that, let me go back through from top and show you how you can tell your answers before you start working. So let's do that. Let me get my highlighter. So form number 3.
This function is bottom heavy. A function is bottom heavy when the highest exponent of x is in the denominator. In order to tell the limit of bottom heavy functions, if x is approaching infinity, and the highest exponent of x is in the numerator is less than the highest x exponent in the denominator, then the limit of such functions would be 0. Now when the exponents of x are equal in the numerator and in the denominator, this is how you tell the limit before evaluating. Once x is approaching infinity, and both are equal in exponent, then the limit of such function would be a ratio of the coefficients of the x's with the highest exponent. My reason for leaving 6 over 2. Now, whenever the x with the highest exponent in the denominator is less than the exponent of x in the numerator, and remember x must be approaching infinity for this to be true, So whenever these three are true, the limit doesn't exist, or some teachers will say it's infinity. And this can be either a positive or negative infinity. Now let's look on a next example.
Yes, so I spent all that time just straightening this up. Right off the bat, we know that this would just be 7 over 8. From what we just learned, right? From what we just learned, we can see that the x cube and there's an x cube here, so both are equal, so we'll get the coefficient of each. And since they're minus sign in front of each, I'll just say that we'll just cancel those. So let's prove that. So this x cube is the highest term in the denominator, so let's prove this. Let me highlight this first. First thing we do, look in our denominator for the x value, the highest power. Here we have 2x value, and this as the highest x power, which is cube. So we'll divide each term by this x cube. So let's do that. When I divide negative 7 by negative 7x cubed divided by x cubed, I'll be left with negative 7 plus 4x squared divided by x cubed. I will just be left with 4, let me write that, 4 over x, right? And this x will be negative, let me write that, 1 over x squared. The last term will just be 2 over x cubed. And all of that is over this. Let me do that. All of that is over negative 8 plus 5 over x plus 9 over x cubed. I'm not liking how this looks, so I'm going to move this down. Okay, so I'm hoping this looks a little better. So now that we have done this, we have divided each term by x cubed. The next step is to find the limit of each term. So when I find the limit of negative 7, I will be left with negative 7, right? When I find the limit of 4 over x, I'll be left with 0. When I find the limit of 1 over x squared, I'll be left with 0. And 2 over x cubed, the limit of that would be 0. All of that is over. The limit of negative 8 would just be negative 8, right? Plus the limit of 5 over x would be 0. Plus the limit of 9 over x squared would just be 0. So my limit would just then be equal to negative 7 over negative 8, which we know would just be 7 over 8. Right? So that's the limit of our question. And if we go back to what we said, it would be, from looking at it, 7 over 8. So now you know you can just look at a function as x approaches infinity and tell the limit of that function. Right? So remember, when the x in the numerator, the highest x power in the numerator is equal to the highest x power in the denominator, then the limit of our question, or the limit of our function, would just be equal to the coefficient of those x term, right? And in this case, even though they are negative 7 and negative 8, we got a positive 7 and a positive 8, is because the negative cancel each other. So that's it for this video. Thank you guys for watching, and please
took a swing at a wrecking ball and I prayed for my downfall.